Hello, good afternoon, everybody. Sorry for the massive delay in releasing the second video. I felt sick and had to travel, hence, I was unable to do so. Thanks for your patience. We'll jump straight into a lesson today. Let's call it lesson two by looking at what variables are. If you remember your calcio calculators, you had these A, B, and C's on it. The question is, what were they used for? They were used to store the calculations which you could further use down the line in more calculations. Computer variables work in the same manner. When you create a variable, it is put inside the memory of the computer where it is accessed and used. It's just a representation of any data at all that you have asked the computer to put inside the memory and that you would fetch it later. You are not using it immediately, but you would what fetch it later. It is what distinguishes computers from calculators. And variables are what distinguish um, programming languages like R, Python, JavaScript, etc., from others like Stata, Excel. Uh, you could use variables in them, but they are not as prominent as you would use in a programming language like R. Now, we should look at the RAM of a computer. RAM for random access memory. Now, picture this as the size of your RAM. It has a fixed space, the gray area, it has a fixed space. So if your RAM is 8 gigabyte, look at this as your RAM. If your RAM is 16 gigabyte, still picture it as twice of this. It wouldn't matter so much for what we are going to do. Now, your operating system is going to take some part of your RAM automatically, whether you like it or not. It is going to use that part. If you are watching this on YouTube, it means the browser you are using to watch has also been allocated a certain amount of RAM which it is working with. If you are playing music as well, or even if the media player is opened but you are not using it, it has been allocated a RAM as well. Now, when you start R through R Studio or even R itself, it's also allocated a certain memory for it to use, for which all variables that you create would be contained in. So when you create a variable, it is stored within the allocation given to R and not outside it. So typically, only R, the R environment would be able to access variables and other data types which have been put inside the R allocation. Any more RAM, any more assignment that you make would also be stored within the same space which has been allocated to R and so forth. Now, R doesn't just put things inside the RAM just like that. It needs to first of all know what type of variable that you've asked it, on the basis of which it will determine the amount of memory that it should allocate for that. Imagine having to store somebody's birthday and R would assign the entirety of the RAM just to store the age of a person. That's quite wasteful. So in most programming languages, you need to determine the type of variable so that it would allocate the appropriate amount of memory for it to use. Okay, so some of the variable types or the data types which you'll be working with are the string, character, or text. We'll use these interchangeably. They mean the same thing, at least for the purpose for which we are having these tutorials. You create a string, character, or text either with a single quote or with double quotes. They are the same, only that you can't interchange them. But if you begin with a single, you must end with a single. If you begin with double, you must end with a double. That is the rule. We will have a demonstration for you to see how these things work. Then there are numbers. Numbers could be integers or they could be numeric. R calls it numeric, but understand numeric as decimal places. We have not exhausted all of it, but beginning, for the beginning, this should suffice. Then there are Boolean or binary values. These these are said to be either true or false. It can't take any more than that. Now in R, you would say true as in all caps or with a small t or with not zero. Not zero means the thing is true. You would denote something false with false spelled all caps or with F or with zero. These mean the same thing and we will have the opportunity to test them. Then there are dates. Dates are either numbers or string or a combination of numbers and string to produce uh, date. Date are quite special in that it's just a combination of the string and the numbers, or it could just be numbers to represent date. We'll experiment with all of them. Then there are other data types, but for now, we are not going to work with them. Then we also need to understand what assignment operators are. We'll delve into assignment operators in the next one, but for now, there are about five of them which you should know. The equal to would come to it. It's a bit tricky because of if you are an English speaker, you would mostly pronounce this as equal to. But in programming, this actually means assign. Now, for that confusion, the next to this, which is the minus and greater than and the minus and less than, are actually often used in R. As a matter of fact, this is more popular. The greater than minus is more popular in R than this sign, that this assignment operator. As I said, there is a certain confusion around it. And for sanity, each time I say equal to, you need to be careful. I wanted to say you need to know I'm referring to this one, but I speak English often as most other Ghanaians do, and it sort of conflicts with how we program or how we sometimes say things. I'll try and be explicit when I want you to use the other which we are yet to mention. But when I say uh, assign, I'll show you a shortcut which you can use to always get this one, or you can just type it by hand. It works the same way. Okay. Then there are the logical operators. Logical operators uh, would produce something as either true or false. There is the exclamation, which is a negation of anything. And you may have seen, you did see it earlier, like the not true here is the negation of zero. So anything not zero, that is how it works. Then there is the end, which is logical end. So this and this. Once again, we'll take our time and walk through all of them. Then there is the or, either this or that. Then there is the element wise and the element wise operators. We'll delve into all of them very soon. Then there are the arithmetic and the relational operators. Arithmetic, you should be familiar with arithmetics to even consider learning R, like plus, minus, multiplication, division. Now, the next one, the modulo and the remainder functions are something we would also experiment with. You can just quickly Google what is the modulo function and see how it works. The last one, this sign is the exponentiation. You could use this or this and you would achieve the same effect. Then there are the relational operators. They tell you the relationship between two objects. So this is in R or in most programming languages. This rather means equals to. You are testing whether what is on the left is equal to what is on the right. The exclamation equal to means not equal to. You want to see if two things are not equal to. Then there is the greater than and greater than or equal to, and the less than and the less than or equal to. We see how all of them will work very soon. With this out of the way, we are going to switch to our studio to have a little experiment to see how these things work for us. So I have my R studio opened already, and we should breeze through it very quickly and see how things work. Okay, just hold on a sec for me whilst I set some things right. Okay, so let me close this. This is the console area. We are not going to use the console for anything. However, we'll just dive straight to the file, new file, and select R. Let's work with the R notebook. Okay, so we'll delete everything here. We don't need any of them for now. And in your own free time, you can experiment with how they are going to work. Okay, so let's practice. We'll start our practice with the strings. Then we'll select R. There's a shortcut for it, which we'll use next, so that we don't go there and always click it. As I said, in order to, let me make it bigger so that I want to zoom in. Okay. So a string is just anything that you type. So I could type like Ghana and we'll click here. This is a string. Once you type it, you would see it in the console, but for this practical, we're actually going to concentrate on the output that will be here. More often than not, it will be the same as the output that is here. So this is a string, Ghana. Now, we talked about variables and maybe we'll use the word Ghana a lot frequently in what we are going to do. So we are going to create a variable and rather assign the variable to assign Ghana as a value for that variable. So I've created a variable which is called CTR. Now, oh, you may not have seen me type all these. Just press Alt minus on your keyboard and it should produce the this assignment operator, which is what we'll be using often. So we are going to run this chunk again. When you run it, there is no output. We have created a variable. I'm sorry, let me just get rid of my environment. Okay, so this is our environment is empty. The environment is the memory that was allocated to R. So we'll run it again and you'll see that there is a variable called CTR which holds the value Ghana. Each time we type CTR, the shortcut to insert the chunk is Control Alt I. If you're on Mac, uh, please, I've forgotten the combination for Mac, but it's the same Control Alt I. I've forgotten. I think Mac has a different name for the control. Just find it under Alt and I. It would insert a new chunk. If you are if you can't find it, you can always press here and click on R to insert the R chunk. As you can see, there are other options, but we are not going to get to them for now. Okay, So now we have created a variable called CTR that holds the value Ghana, and we can test it by simply typing CTR here and run this chunk. You see, it gives us Ghana. If we were to even type CTR here as well, we also expect the value Ghana. Now, if you the benefit of all these will come in when once we start moving on to more formal analysis of data. But for now, you are going to create variables this way and you'll just see your output this way. So as I said, you can create one. I created this variable with double quotes. We can create one with a single quote. So as an example, uh, city, I'm creating a variable called city and it's going to hold the value Kumasi. We can check what city contains. You don't need to come and type it in the new line, in new chunk as I did here. You can perform many calculations in a single chunk. So once this is done, as you can see, city now holds the value Kumasi and you can verify it over here. Okay, so to continue, we said your uh, it must or it can begin with a small a single quote or a double quote, but it can't be you can't mix it, and that is true. So for instance, if I were to, since we are not going to use this, I'll type this in the console, like want to create a variable and call it Nigeria, our uh, our brothers. This would, you would realize that it hasn't worked. If you are in this situation, kindly press escape on your keyboard to exit this. This will not work. But if I were to do Nigeria, it would give us the output. The same way as you can't begin with uh, a double and end with a single, it also doesn't work. You must, if you don't want trouble, you must close it before you get any level of sanity. This is error. Don't even try it. If for some strange reasons, if for some strange reasons you need to have a mixture of both, I think there are some countries which have fine. You could do something like, yes, you can escape it within the text, but basically you must begin and end with the same number of quotes as you are beginning with. You can't mix both of them. Okay, if I may continue here, we are going to experiment with numbers. Okay, so age, we can use this, but please let's avoid it and use this. So age is equal to 12. Definitely not my real age. So we now have a variable called age which holds what, 12, and we can actually confirm that it holds the value 12. If for some reason I know my weight, I could say I weigh 13.5. Yes, this is also a valid number. You can see both outputs over there. All these are numbers. I'll treat them the same way. We would not work with dates for now because working with them is a bit more complex. So for now, we are going to leave it here. having experimented with strings and numbers. But I leave it here. I mean, we are going to continue. Let's work with booleans and wrap it up for this particular section. So, booleans, Control Alt I. Okay, so boolean value, we can have true. Um, am I a nice person? I'm saying T for true. It's the same. Yes. So nice holds a value true. If we are to type nice inside the console, it will give us true. T means true, and we said it. We've said that already. I actually prefer typing T and F and not typing everything in full. Life is too short to be typing a lot. Okay. Now R is case sensitive, and this is a good time for me to bring this up. So when you type this, it's not the same as typing this. Neither is it the same as typing this. R is case sensitive. You may have noticed that as I type, suggestions pop up. This is called intelligence, and it's one of the reasons why we use an ID, integrated development environment, because of intelligence. It saves you a lot of time. So if I wanted to insert this, I'll just press tab, or I can press enter, and it would insert the one that it has highlighted for me. Okay, this is the time to also check on the logical operators. So we can have T equals to true. This is true equals to true, and the answer is yes. True is equals to true. Is true equals to false? The answer is false. True is never equals to false. Is false equals to false? Once again, the answer is what? True. You use logical operators. They don't need to be booleans on each side. So for instance, I can check whether 12 is equals to 17, and we expect a false for an answer. Yes, 12 is never equals to 17. Is 12 equals to is 12.0 equals to 12. Now, what do you think the answer is going to be? I want you to say it before I actually execute this line of the code. In R, 12.0 will tell you that it is the same as 12. At a certain decimal, though, it still says true. Yes, I don't think anybody is ever going to test this. These are edge situations. I think it checks for 8 zeros. Once the 8 of them are zeros, it ignores whatsoever is afterwards. But this is definitely not equals to this. This is false. Okay. So, for instance, we talked about not equal to. So, 12 not equals to 17. The answer is true. 12 is not equals to 17. So, we expect there to be what? A true. Now, we also talked about the negation operator. 12 equals to 17. We expect 12 equals to 17 to be true, to be false. But because we have put the not operator in front of it, it will give us what? True. Understand this particular operation this way. 12 equals to 17. The result is what? False. So not false. If it's not false, it's definitely not true. So that is how uh, the logical operators also work. Okay. Uh, in our next section, we'll talk about the uh, comparisons greater than and other things. We may skip it because you could just do it's 12 greater than 4. The answer is true. These things are very basic, and a little understanding of mathematics is sufficient over here. So maybe we'll not spend that time to work over each and every one of them. What we'll do is the comparison operators. We'll start right on from there and move on. So I thank you for coming and staying with me throughout this video. Uh, I encourage you to like the video. This is a very young channel, and these likes are very important. Therefore, if you did really enjoy it, you should press the like button. Have a wonderful day.